So Boyles' law, a bike pump cylinder holds 0.75 liters of gas. What variable did I just get?
You just got volume.
Of air at standard pressure. So what are they telling me about the pressure?
That it's 1 ATM standard?
Standard pressure is, yeah, right, 1 atmosphere.
Okay.
Okay, but here's the problem. They gave us kilopascals over there.
So 101.3 kilopascals.
So this is 101.3 kPa.
We get to do like a stoichiometry type problem.
Well, you might have to convert, but you're not going to have to now because we've already converted the 1 atmospheres to kPa.
Okay.
They want the new volume, so that's my V2. And they've given us our new pressure.
So you have V1, V2, P1, P2.
Well, you have V1, you have P1, but you don't have this one. That's the one you're solving for.
Okay.
So we're going to use Boyle's law, which says that P1V1 is equal to P2V2. And then we just stick in the numbers. So stick in the numbers for me.
0.75, or that's volume, and then 101.3 kPa. Is equal to V, yeah, and then 810.4 kPa.
Before I do any math, what happened to the volume? I mean, what happened to the pressure?
It increased.
So what should happen to our volume?
It should have to decrease.
It should have to decrease. So we divide both sides by that. And you got a calculator over there. Tell me what our volume is.
$10.4. 0.125.
Did our volume go down?
Yes.
Yes, it did.
And I suppose you can just check by multiplying it out, but I'm sure that's right.
Yes, I'm sure that's right. All right?
Yep.
Okay.
That's not too hard.
Nope. I will let you try to figure out the next one. Let me, if I can delete this thing. Clear the whole board. All right. And I'll copy this one. Copy. And then we'll go to text box. And then we'll hit paste. And then we'll change the font size. And then we'll hit enter.
I think you have to click.
Did I click?
Like just click on the screen anywhere. And like get it out of that text box. Yeah, there you go. Yeah, like that.
And then go down to that. And then. All right. So you read that question and tell me what to write.
All right. Charles law. A balloon has a volume of 0.50 liters at standard temperature. What would be the new volume at 90? What does that say? OC? What is OC?
That's 900 degrees Celsius.
Oh, that's a zero. I thought that looked like an O for a minute there. Okay.
Or that's supposed to be 90 degrees Celsius instead of 900.
Oh.
Because that is a misprint. Like that's supposed to be a degree symbol. Like.
Okay, that makes sense.
I guess it doesn't matter. We can just do it anyway. Okay. So what information did you get there?
You got the volume.
What information did you get here?
You mean standard temperature. So.
What is standard temperature?
Oh, is that it? Just 273.15.
It's 0 degrees Celsius is standard temperature.
Oh, okay. So
which is 273.15 degrees Kelvin. They want us to find our new volume. And then we got to change this to what?
Kelvin.
This is T1. So now I need to set.
T2.
So tell me what T2 is going to be equal to.
It's Celsius. So you have to add 273. So 290, 363 degrees Kelvin. 363, right? Yeah.
We'll just leave it like that.
Okay.
All right. So what is Charles' law?
V1 over T1 equals V2 over T2.
All right. Stick in your numbers.
All right. So 0.50 L over 273. Do I need to put the 1.15? Because, okay. Over. All right.
So what happened to our temperature?
It increased.
So what should happen to our volume?
It should also increase.
So solve for V2. What do you do?
I have to times both sides by 363. What was it? 363. Yeah. 999 equals V. So then you just divide.
Wait a minute. Why is that number so big?
I don't know. 27.
You don't multiply both of them by that. You just multiply the top by the top and divide by the bottom.
That would make sense because that's a really big number. .665. So it increased. Alright, that's not too hard at all.
Pretty simple.